So, welcome to Lead's webinar on becoming an engineer, roadmap from high school to high impact career. I'm happy to introduce Mr. Darren Leung. Darren is a mechanical engineer and holds a bachelor's and a master's degree in mechanical and aerospace engineering from UC Irvine. He is also a current instructor at Elite. So, without further ado, Mr. Darren, you can take it away.
Thanks, Julian. Again, good evening, everybody. Like Julian mentioned, I got my bachelor's and master's degree at UC Irvine. I also came to Elite with a bachelor's in education, so I combined the two together. So I teach mostly math and science here at Elite at both the Cerritos branch and the Irvine Newport Beach branch. All right, so let's talk about how to become an engineer. All right. So I would say a lot of engineers, they usually start out by building stuff. For example, Legos. My journey personally, I didn't have any Legos. So instead of building stuff, I took stuff apart. And my parents weren't too happy about that at the time, but I would say they're pretty happy now that I'm an engineer. We do this because we want to know how things work, specifically the mechanisms behind everything. So not only we can learn from the current mechanisms that were in the past to solve the future problems, but we also want to learn what mistakes were made to get to those mechanisms, right? Pretty much we learn from our past. A kind of a not great example to say for engineers is that the rules of engineering are written in blood, as in we've lost a lot of people, we've lost a lot of money due to engineering mistakes. So part of being an engineer is being able to learn from your past. We learn from our past to predict the future, essentially, right? So we learn the math and physics primarily so that we can then serve the public the best way we can. Those math and physics classes, and as well as experience, helps us build our professional judgment that we have as engineers. There is a social contract between the engineer and its public. So, for example, the room that you're sitting in right now, the school that you attend, the roads and bridges that you drive on, I can probably bet that a lot of you had no experience or knowledge on how any of those were made, but we trust the engineers that came before us to keep us all safe. So that's what I mean about being able to predict the future and serving the public. All right, so what was my high school journey? I do want to note that becoming an engineer is not one size fits all. So whatever worked for me is probably not going to work for you. Everyone is different, so embrace that difference. This is literally all I did in high school that pertains to my math and science classes. I really didn't do much. I didn't manage my time that well in high school, to be honest. I didn't really feel like I was that included in high school. And I also couldn't think for myself. So I mostly kept with the math and the science, all my academic classes. And I really committed to my extracurricular, which was cross country and track and field. I'm a big runner, if you can tell by my background. So the summary I have of what I did in high school is that I went to school and I ran, but I still came out as an engineer in the end of the day. So if you're doing more than what I am or what I did, good for you. Keep doing that. Although if you are not in that camp, maybe your school doesn't have the resources or your parents don't have the resources, it's not the end of the world, right? As long as you have the passion, you can definitely make it as an engineer. So most of you are probably in high school. I'm not sure if we have any middle schoolers or youngsters on the call. Um, but if you're in high school, what classes are actually important to become an engineer? You'll notice all of these are math and science classes at the highest level. So the bridges I mentioned before, the roads I mentioned before, your room, your school, etc. Who's building that? You don't know who they are, but you hope that they passed their math and science classes with flying colors, right? Keep in mind, you don't need to take all these classes, but I would say you should take the ones that count the most for your field of study, whatever that may be. So, for example, me being a mechanical engineer, I don't need to know that much chemistry or biology unless I do. So what do I mean by that? Mechanical engineers may sometimes work on biomedical engineering fields, so they'll maybe need a little bit of bio. A lot of the engineering fields have a lot of intersections. So just because you take a major in one field doesn't mean you can't work in the other field as well. It's actually very common for engineers to become doctors, actual medical doctors, or even go to law school because they learned additional skills there, for example. Right. Besides the classes, what else can you do to boost your chances of getting into an engineering school? Extracurriculars. Everything that you do outside of school matters, and you can learn a lot from them. So here we have a few examples, such as robotics, science Olympiad, math club, engineering club, and coding. Like I mentioned, I didn't do much in high school. I didn't do any of these. I mostly focused on the project-based activities, not so much in high school, but in college. But if you can get ahead of the rest of the field, you're gonna give yourself a better chance for sure. Again, you don't need to do all of these, but at least do something, even if it's not related to math or science, because you will still gain other professional skills, such as working in a team, taking leadership, public speaking, and so on. Me being a mechanical engineer, I can only speak for myself. Any project-based activities will help you out for sure. All right, so continuing on to the extracurriculars for future engineers, I would say a lot of these are more applicable for college students, but if your high school happens to offer this or if you have connections in the industry, um, make use of those, right? Don't burn down your bridges, keep building the bridges, metaphorically, of course. But just like your extracurriculars, you'll want to utilize your summers. So during your summer, what do most high school students do? We relax, we hang out with friends, we go somewhere with family, like a big trip or whatever, right? That's important. You need to balance out your life, take some breaks. But I would argue that there are better things than scrolling on the internet all day. I was one of those people. I wish I did this earlier. Um, okay, so that's the question that I'm going to pose to everyone. What's better than scrolling on the internet all day over the summer? Me being an engineer now, I'll say making money at a part-time internship that pays you. That not only do you get paid for it, you also gain the experience that you can then tell your story about. If you don't want to find an internship, you can also go to a community college, take other higher level classes so that you can demonstrate in your application you are ready for an engineering curriculum. Not to mention, it can also help you save time and money by giving you credit in those classes. So long story short, utilize your summers. You can also create a portfolio if you can. Fantastic, do so. If not, don't sweat it. In my opinion, I would say that a portfolio only shows what you have really done. And a lot of engineering jobs and schools want to see how well can you work with others as well, besides just how smart you are, right? So let's think about this real quick as a thought experiment. Let's say you are in a company trying to build like a toy car, for example. Um, what are the different teams that might have to go into making that product a reality, right? You're going to have a marketing team that it's going to ask you to cut cost. You're going to have a design team that's going to ask you to enhance durability and funness, if you will. There's going to be a packaging team that's also going to try to cut costs as well, and so on and so forth. Everyone's going to have a different opinion, and so being able to work in a team uh, together like that is something you're going to want to build on as a skill. And again, in the end of the day, whatever you submit to your colleges or to your jobs in the future are just trying to show that you're ready to take on the rigors of engineering, whether that's in college or in the real world. All right, what else matters? Your test scores. You've probably heard that maybe not as much as they used to, but they still matter quite a bit. So this can really help you out if you don't have as much experience to share like I did in high school. Um, like I mentioned at the top, engineers got to be really, really proficient in math and science at the highest of all levels. So in your college apps, if you're going to apply as an engineer, as an engineering major, I mean, they're going to want to see essentially perfect scores on math and science AP exams, as well as your science and math ACTs and SATs. If you're thinking, oh, wait, I don't have that right now, you still got time, right? You still got time to figure that out, consult the resources on how you can get there to achieve your goals, right? I'll be honest about my test scores. I wasn't great at English, but I knew I was very strong at math and science. So I hammered home on those strengths of mine. As a result, I got fives on my APs. I got 800s, 36s, 1200s, whichever you want to call it. They keep changing the scoring systems for all the standardized tests. But I got perfect scores on my math and science sections, which helped make up for the things I was lacking, such as my experience and my English scores, at least. So I often repeat this to all my students who do want to become engineers. You really have to have that attention to detail in order to accomplish those high scores in math and science. What else is there? Having a high English score only helps you. So if you're finding yourself, well, I don't have a problem with math, I don't have a problem in English. Let that fuel your growth and fuel your trajectory to becoming an engineer, right? But at the very, very minimum, you're going to want to have very high math and science across the board, right? And so here's a list of colleges that we have, or a brief list of colleges that we have, typically the bigger names. We have the Caltechs and MITs of the world. These types of colleges, I would say, are more interested on can you just do the math? They don't really look too much into, well, are you a sociable person? Are you a well-rounded person? Of course, they still care about that, but they are on the cutting edge of knowledge on all engineering topics. So they really want to have the best of the best. The other universities on this list, they are going to be looking for a more well-rounded students. So the chances of you getting into one of these universities is more likely. Okay, next slide. All right. So this is my advice for current high school students. These are all things I wish I knew in high school. Number one being to tell your story. We're all unique people. For example, we're all crossing paths right now at this webinar. So the question that I want to know if I'm going to be admitting one of you to like a job or a college, if I were in that position of power, would be, well, how did you get here? What inspired you to get here? Why do you want to be here? And so on. Um, and right, high school, you can explore what your interests are, right? Explore your STEMs, classes, and experiences, whether if you have a robotics class or robotics club at your school. Definitely take part in that. And if not, take the initiative and start one. That shows a lot of leadership. What else? You're always going to be learning and growing. You're going to make mistakes. I still make mistakes every day at my job, um, but we learn from them, right? That's the key thing, to learn from your mistakes. Um, if you continue making the same mistakes over and over again, trust me, that is the quickest way to get fired from your job. Right? So talk about your growth. How did you learn from your mistakes? Right? That's what you want to do. Right? Your interests will change over time. Oftentimes we're told figure out what you want to do in your life, figure out what you like to do in your life, what's your meaning in life, for example. Um, I would argue part of that equation is figuring out what you don't like as well, right? If how will I ever know what I like if I don't know what I don't like? So don't be afraid to go out and try new things. There's no need to plan super far out in advance, um, but truth be told, that an engineer is always one step ahead into the future. We all probably lived through this during COVID. Can you believe it? Now, almost 6 years ago, 5 to 6 years ago, right? But if you rewind back to 2019, and we all kind of had a plan of what's going to happen. Okay, I'm going to do X, Y, and Z in the next 1, 2 years. I'm going to either go get a job, I'm going to apply to a college, what have you. Then all of that changed, and all of a sudden we had to adjust to that. Being a good engineer also means to work with different constraints. All right, so all of these things that I'm mentioning now is essentially your college essay. So I put together essentially a very, very brief summary of what I would view as an ineffective college essay versus an effective college essay. Again, a lot of the prompts these days are very much so that you can talk about your origin, your story, right? So an example of an ineffective college essay was that I was great at these classes. I scored super high on these exams. I did a bunch of extracurriculars in my free time. I have no free time. I don't sleep. I live, eat, and breathe engineering. That's why I should go to this college. The questions that I'm still wondering are, okay, that's great and all, but so what? And why should I care? What did you learn from these? And why did you do these? These are questions that you're going to want to answer in your college application. So rather than leaving the reader slash admissions officer guessing, talk about it, right? This was literally my grad school application in a nutshell. Um, I said I found a problem that I didn't like, but I had the knowledge and skills to fix the problem, or I want to obtain that knowledge and skill to fix the problem to make the world a better place. And I wanted to become an engineer because I this was my origin story, and this is how I got to the point where I am. Through my opportunities, such as my senior design project, I learned, I failed, and this is how I got here, right? But then I elaborated further to say, well, um, I'm still learning. I think this college is the best fit for me, and that's why I belong to this program. All right. So again, talk about not just your accomplishments, but what you took away from them. Same thing when you do go to college. All right. So one of my more favorite parts, I would say, is you've gotten through high school, you submitted your college apps, you're off to the races in engineering school. What should you expect? All right, your first and second year classes are going to focus heavily on your math and sciences in addition to your GEs. That sounds like a lot already. Um, I would say a lot of high school students probably take between 5 and 7 classes. Consider the equivalent to be 3 or 4 classes in college. Um, there are people that take more just so that they can try to get through it faster, but knowing your limits is something that you will figure out in college as well. But regardless of how many classes you take, it still will be heavy on math and science in those first 2 years. The example ones here that you absolutely need to know are multivariable calculus, differential equations, physics, uh, general chemistry if for most disciplines, organic chemistry on certain disciplines, CAD if you're a mechanical engineer, statics and dynamics if you're mechanical and civil, and thermal kind of across the board as well, right? Uh, in the engineering world, we kind of consider these to be the weeder classes or the filter classes because the whole purpose of these classes are to filter out um, the students who don't have the passion, who don't want to put in the time, the effort to try to do well in these classes, right? So these are very tough classes, and a lot of the times your professors will not be holding your hand through these classes. Um, so you're on your own for the most part. You need to figure out what's the best way that I learn? Uh, who can I talk to? Who can I collaborate with? So on and so forth. Right? After the first 2 years, once you get through those foundational classes, you're going to use the skills you learn from those classes into your more specific classes in your third and fourth, possibly fifth years. For me, I focused on fluid mechanics. I really love fluid mechanics. Essentially, what that means is that I study the air, the water, and other fluids that exist out there. Um, One of my more proud accomplishments that I did in the industry was study how fire behaves. I never learned that in college, but it was super, super exciting to learn about how fire behaves because when you think about it, fire is fed with air and is um, extinguished by CO2 or water. Okay, but then you're going to need chemistry to understand that process a little bit. You're going to need physics to figure out how does the air molecule affect the fire, how does it flow, what are the temperature changes. That's where the thermodynamics pops in. We also have vibrations, literally things shaking. So vibrations is going to be a big topic in buildings and bridges. If any of you know Tacoma Narrows Bridge, that's a vibrations problem right there. Controls, this is more so electronic based, and heat transfer. These are all the classes that I took too. But besides mechanical engineering, these are a handful of classes that you'll also take in the other disciplines. Also, I was an aerospace engineer, so I also did learn how to build an airplane. So how do wings work? How do turboprops work? How do engines work? Essentially, I also tell people, oh, as an aerospace engineer, you're learning how to build a rocket. You're trying to build an airplane, something along those lines. And this shouldn't really be a separate year because your senior year and your fourth year are equivalent, but you're going to most likely have a senior design project where you're going to kind of bridge the gap between what goes on in the industry and what goes on in your academics. So classic one, like I kind of mentioned it already, is building a rocket. A lot of colleges, including UC Irvine, they have a rocket team where you are working with a professor that's knowledgeable in the field and literally building a rocket. Another one is solar car, build a solar powered car, solar airplane, um, just to name a few. All right. So like I said, there are a lot of classes that you're going to take. Here are the classes that I liked. Here are the classes that I have flashbacks on that I don't want to repeat. Um, this might apply the same for you. It might not. In the end of the day, a lot of the classes will depend on your professor. Um, Sometimes there's only one professor available to teach that class, so that's where you're on your own. Um, but if you happen to have a good professor that's good at teaching and is there to help you out, they have the passion to teach, then I promise you that will be a well-deserved class that you get a good grade on. And I like to put this phrase here. This was literally the biggest bang for my buck because if you don't know already, right, you have to pay for your college classes and your textbooks. So um, each of these classes are worth the same amount in terms of dollars, um, as well as the classes on the right hand side. I got the most out of these classes. Next slide here. All right. So we're back to extracurriculars. So it's the same question as before, but this time you're in college. What do you do in your spare time? So being a college student is considered having a part-time job, and what that means is roughly 20 to 30 hours of work per week. That includes going to your lectures, going to your discussion classes if those are present, and then doing your homework as well. Um, so then if a standard work week is anywhere between 40 and 50 hours a week, then what are you doing in the other 20 to 30 hours of your spare time? Well, here's a list of things that you can do. I tried a handful of these, and like I mentioned before, part of recognizing what you like is recognizing what you don't like. I tried research and I hated it, so I tried something else. I didn't do internships, unfortunately. That is probably one of my biggest regrets in college. So anyone's taking notes for whatever reason, right? Definitely utilize those internships if you can. Um, I was a part of the automotive project, which was Formula SAE. Essentially, I was part of the team to build a Formula One car, and we didn't get a chance to compete because of COVID. So that was quite a bittersweet moment. Um, and I was on that team for 2.5 years roughly, and I liked it enough that I naturally started to take on more responsibilities and became fairly well known around the group. Obviously, until I left. But the lesson learned that I took from this was that you don't need to spread yourself out so much that you spread yourself too thin. Find the things that make you happy, that make you want to get up out of bed to go do that type of work. All right. Okay. So advice for college. Why do you need to do all these other things outside of school? Pretty much is the question that I would pose. Well, everything in school that you learn, all the classes that I flashed earlier, those are theoretical. Those take place in perfect conditions and are purely for academic purposes, hence academia, right? Everything else done outside of academia is the experience that you gain for working in the real world, right? And this applies to both college and high school. So if you're able to get into that robotics class or robotics club, for example, you're going to learn so much more in that class than all of your math classes combined, probably, right? And so the whole purpose of these projects and internships is for you to bridge that gap between you getting a job post grad and where you are now in high school or early on in college. Keep in mind that when you do find a real job, people are paying you a lot. There's a lot of money being poured into projects. Think AI, for example. So they're going to want you to be perfect pretty much. And if not, you're out. But then how can you kind of learn that through your internships, through your projects? You can make more mistakes there and learn from them before you make them in the real world. All right. So these next couple slides are just briefly talking about what are the different types of engineering fields out there. Mechanical has to be first because I'm mechanical, but it's also the broadest of all fields. There's a common saying, which is if you don't know what to do for engineering, but you want to become an engineer, do mechanical. Um, there's also electrical engineering for people who like electricity for whatever reason. High voltage power lines or even low voltage is fine too, but typically we think of high voltage stuff. Computer engineering and software engineering, there are some nuances between the two. That's why they do have their own separate fields. Um, Computer engineering and computer science engineering are often coupled together in the engineering department, but I do know that UCI, for example, they do have their own separate computer science department. So if anyone listening is interested in computer science and wants a dedicated department, well, that's where UCI comes in to fit that bill. All right, civil engineering, bridges, roads, buildings, also a very popular field, um, just because it's probably the most apparent one, right? We all take the roads, we all take the bridges, and we don't think about the engineers who help build those or help make them a reality. And sometimes that's the nice part about being an engineer. You work behind the scenes, you help people out, and people don't think about you as much. I personally enjoy that the most. Chemical engineering ties a little bit into nuclear engineering, but they're their own separate field, of course. Biomedical, if anyone's interested in potentially going down the pre-med route, this is very common to become biomedical, and then eventually going to medical school, right? Um, I can't answer much about the MCAT, so please don't ask questions about the MCAT. Uh, but you have to take it, of course. Industrial engineering, there's also petroleum engineering, right? There's just so many types of engineering out there that there's not enough space or time to discuss them. Aerospace, one of my other favorites. You're building rockets, you're building spacecraft, satellites, airplanes, jet engines, you name it. So super, super exciting field because again, I was really interested in fluid dynamics. So I wanted to study how does an airplane fly. I'm sure we all thought of that at some point. Um, there's an engineering field for everybody. So if yours is not on here, trust me, it still exists. All right. So how do you choose the right field of engineering? Here are a couple steps that you can follow. Uh, you're gonna have to be passionate though. You're gonna have to be passionate about math, physics, all the sciences. Like I mentioned before, math and science you just have to have. Um, and then let's think about it. If someone hires you as an engineer, what are they gonna have you do? They're gonna have you solve a problem that they haven't figured out yet. So you're gonna solve new problems that you probably never learned in school, right? Because everything you're learning in school is everything that's been taught for the past 400 some years, right? But you're trying to solve the problems of tomorrow and 5, 10 years down the road. How are you going to do that? You're going to do that using what you know now. You're gonna work with others that are experts in their field as well, right? Figure out what industries excite you, long-term career goals, work-life balance. Um, I would say most engineering fields have a long-term plan for you and have pretty solid work-life balance, but every job is different out there. So in the end of the day, just find what you're interested in. Find something that will get you out of bed in the morning. All right. Do I need a master's degree for engineering? Um, like most answers in the real world, the answer is it depends. Some fields require it, some don't. For example, if you are doing research, you're most likely going to need a PhD. If you're going to be working on classified information or classified projects, you'll probably want to have a master's degree or a bachelor's with a lot of experience or a friend that you know. Um, does it lead to higher pay? Again, in most cases, yes, but sometimes no. So don't go just for money. And is there such thing as being overqualified? Absolutely. So in some cases, more is not better. A PhD example being the highest of all degrees, given the standard bachelor's, master's, and PhDs, can push you out of the job market a little bit, right? So the way I like to think about it is that getting a bachelor's is to just get a job. A master's degree is to show that you can demonstrate a little bit more proficiency, hence the word master in that. And then a PhD essentially means you are on the cutting edge of a very small piece of knowledge, but you are on the edge. You are the expert in that field, right? And again, masters and PhDs, these are research degrees. So masters, not so much on the cutting edge of knowledge, but PhDs for sure. And all your professors at a university will most likely have a PhD. So they are also conducting research. Um, if you don't want to get a master's, that's okay. What actually matters in industry is your experience and your licensure. So going out to get your license, to getting a professional engineer license, or known as your PE exam, or passing your PE exam. All right. But we keep hearing about AI, right? AI is coming for my job, so they say. AI is going to be the future, so they say. Well, in the past, we also thought that bank tellers and cashiers would be out of the job forever, but we still have them, right? The technology that comes in the future, yeah, it takes some jobs away, but it also creates new ones as well. Think of the renewable energy industry. People were concerned about the petroleum industry going under. Well, the renewable industry, or the renewable energy industry, is also booming as a result, or the jobs that transfer from the petroleum sector go into the renewable sector, right? And so the same thing has applied ever since new technologies come out, right? So AI is still growing. We don't know what the future is going to be, of course, but if we had to go back to the past and read the story, it would probably tell a similar story. Um, and let's be honest, right? We still don't have self-driving cars. We still don't have flying cars, even though it was displayed so many times in the past, right? So technology is slow to grow, right? Engineering is still a very valuable field to be in. It does offer a lot of flexibility, even if AI does come and take over in a sense. Um, what you learn in engineering, you also learn the different skills required to be a good worker, right? So, um, like I mentioned, AI taking some jobs away, it opens up other ones too. Software engineering is on the rise. All of these are on the rise and continuing to grow, right? So, kind of to start wrapping things up, right? Knowing a lot, so getting good grades in class is important, but you also need to know how to work as a team, right? With AI, for example, it's not just knowing how to use AI, but how to use it effectively, right? Because you hear of the horror stories of students using AI to cheat. Those people are not making it very far, right? You want to use AI as a tool. Let's be honest, right? AI is here to stay, just like all the other technology that's come before us, right? So the people that came before us, well, we don't know how to use AI. So that's going to be your strength. Okay. You're going to want to learn how to use AI effectively, but then you don't want AI to substitute the skills that you didn't want to learn, like math and science. Right. Again, this kind of just summarizes everything that I just said, right? AI is going to stay, and it's going to help us if we use it wisely. All right. Again, how do you compete with AI in a sense, right? You're not really competing with AI. You want to know how to work with it. So AI can be a very powerful tool if you use it properly. Prioritize creativity and problem solving, right? You as a human, find what makes you you. What makes you stand out compared to AI or a calculator, right? Have you seen AI art recently? Is AI ever going to replace art? Probably not. We're still going to rely on humans um, to take care of that. And plus, it also depends on what the demand is. I would say most of us don't want to have an AI teacher or purchase AI art. Sure, they're great and all, but they lack a little bit of substance sometimes, right? And so we'll still want to have people around to take those roles. All right. So to sum up everything in a nutshell, what I wish I knew what an engineer was going out of high school and into college, right? Engineering pays a lot, but don't go into engineering for just the money. You need to have the passion. You need to be curious. That is going to value so much more in the long run. This is what's going to get you out of bed in the morning, not the money. All right. Experience matters a lot than your grades because, again, everything in school, theoretical. Everything in the real world is actually has substance to it, so to speak. Right? It's not about what you know, it's about who you know. So, like I mentioned earlier, if you want to work on classified projects, you probably won't, to be honest. But let's say you're trying to find a job. If you have a friend, you built some bridges along the way, they might help you out a little bit, right? If someone came to you and asked, like, "Hey, I'm having a hard time with this, but we've known each other for quite a while. Would you be able to, put my resume out there? Would you help me get my resume to your employer, for example?" I'm sure most of you would say, "Yeah, not a problem." Right? And again, licensure matters a lot more. You need to pass your FE exam, which is kind of like getting your learner's permit on how to drive, and then your PE exam, which is your actual license, using the same analogy there. These are critical, right? For some reason in college I was told that none of these matter. Yeah, don't listen to that. Right? These absolutely matter, and some companies might give you a salary boost because of these. What else? Embrace your failures, right? You're gonna make mistakes. Don't beat yourself up too hard about it. You're not gonna know how to do everything, so ask questions. You're better off asking questions um, than making a mistake. Also, think about it. You studying with your friends, for example. Um, if your friend asks you a question, how many of you are thinking, "Oh my gosh, you ask way too many questions. No, I don't want to help you anymore." Right? It's the same thing when you have other people that are experts. Don't be afraid to ask them questions. Know how to respectfully butt heads with people. Engineers are notoriously very opinionated people. So you ask five engineers a question, you'll get six different answers, right? You're gonna want to know how to balance all of that out. Being an engineer also is a very fine balancing act. Like I mentioned also, right, you're going to want to utilize all the limited time that you have. That means including the summer and your free time as an undergrad in college. Um, the college that you do end up going to, don't go for just the name. Everyone wants to go to the MIT, the Caltechs of the world, and the Berkeleys and the UCLAs of the world, right? Too often the student tries to fit into the college, so they change their personality to fit the college. Remember that the college is there to serve you. You pay the college to get the degree, so the college should serve you, right? So find what is the best college fit for you. And you can do that by visiting the campuses. Um, don't go during their breaks because then everyone's gonna say the same thing. Ooh, ah, the buildings are so nice. Wow, it's so quiet here. Well, yeah, because everyone's not in school, so you don't see anything about what college life was like, right? So maybe on your spring break, that's a very common time to go college touring, right? Colleges are still in session. Uh, and when you do choose a college, right, not just okay, this is the college for me, but also consider the financial cost of it. Talk to your family about it. How are you going to support it? There's going to be a fit for you, right? You just have to find where that is. Um, and here's a quote at the end of the day to kind of wrap everything up here is right. You want to try different areas to discover what excites you. Your path doesn't have to be linear. I'll add to that. It doesn't have to be the same as anybody else's. And whatever you explore will lead to your discovery. And with that, I'd like to say thank you for listening to me talk for the past 40 some minutes. And I'll open the floor up to any questions you have.
Yes, thank you, Darren. So we have some questions here, but the rest of y'all, if you have some questions, go ahead and post it in the Q&A, and then we'll get to them in turn. Okay.
So thank you again, Darren, for taking the time to kind of explain your journey. We had some questions trickle in as you were speaking. So I'm just going to go ahead and read off some of these for
That's
you.
good.
Okay, so we have a question here. Where do you currently work? And kind of going off on top of that, I think this person is a little bit concerned that, they don't see engineers, or there's a kind of this perception that there are many engineers without any work right now. So I guess we could start off with where do you currently work and maybe address that second part as well.
Yes, very good question. Right now, well, I'll talk about my past first, just because I do have a newer job. My last job was at a fire protection engineering company. So I graduated as a mechanical engineer, and that's where I learned how fire works in buildings and how to keep people safe from fire in buildings, right? I learned a lot about how fire behaves, why there are so many cases. There's so many case studies of buildings on fire, um, and unfortunately, too many deaths. So that's why I mentioned at the top, the rules of engineering are written in blood. We need to learn from those mistakes so that they don't happen again. Right now, I currently work for a company focusing on building data centers. Ooh, that's going to draw a lot of, oh, that's related to AI, right? Yes, that is. Oh, what companies do you work for then? I cannot say. A lot of that is um, very quiet. So that's also kind of what I mentioned before, which was if you are going to go onto any classified projects, yeah, maybe your friend might bring you on, but they probably can't tell you anything until you get in there. So take fire protection, for example, because that was probably where I had more experience in. Um, how is AI going to design a building that looks nice to the public, that serves the public, um, that knows what fire is and how to think about all the different types of fires that happen in a building? And then how does it solve those problems? Right? We have software to help figure that out for a lot of us, but AI can't input those parameters just yet. Um, I'm not sure if they ever will because there are so many things that we have to consider, so many constraints that AI is just too concrete like that, whereas it's more of a gray area in the real world.
Okay. And then this is kind of a two-parter question. This individual's wondering, okay, what if someone's interested in electrical engineering? Kind of what that path might look like. I think we covered a little bit of that in the
Mm-hmm.
presentation. But also, they were asking, so UC Berkeley has a EECS dual major. I know currently they have two joint major programs. One's with the ECS Materials and Science Engineering joint program, and then the nuclear engineering program. So
Mhm.
maybe just a little bit insight onto that and how that might apply in the professional field.
I can't speak too much about UC Berkeley just because they have their own program. I can't even speak on behalf of the electrical engineering program at UCI, but I can say this, which is these are all just fancy titles, right? And at the end of the day, the piece of paper you get, you're still an engineer, right? If you look at yourself in the mirror and say, yeah, I'm an engineer because I did all these classes and I got my engineering degree, that's all that matters, really, right? It's just a label. Like I mentioned, I graduated as mechanical, but I went into fire protection. I I had a friend in college who went from art as an art major to an engineering major and works at a big aerospace company. Um, One of my professors was electrical engineering, and they were a psychology professor. Literally, you can go into anything. It just depends on what you want to do, right? I would say, of course, go to the major that is most closely aligned to um, where you do see yourself going. But just know it's not end all be all if you don't.
Excellent. Um, Got another question here. How important is coding for engineering? And then kind of any, what kind of coding programs would you say are most important to learn to be successful? Let's say Python, Java, C++, etc.
Yeah, really good question. And the answer is it depends. My job right now, I don't do any coding. At my last job, I used a little bit of coding using Python. Did I learn C? Did I learn Java? Yes. Did I like either of them? Probably not. All right. So whatever you can do to help build yourself up to say, well, I can code in Python, I can code in Java. Like it doesn't really matter the specifics of it because you know how to code. That's all I care about. Then can you write a program? If I gave you a program, but it's done in C, for example, but you only know Python, can you figure it out? Probably. So I'm okay with that, right? Hopefully that answers the question.
Yes, I think it does. Um, Another individual's asking, can you explain more about the engineering licensing or licensure exams, please? Any more detail or insight?
Yeah, they're just a summary of pretty much everything you learned in college, and also there's going to be something that you didn't learn in college as well. So surprisingly, for example, my degree did not require me to take any type of statistics. So I don't know much about AP stats. So if some of you have AP stats in your background, great, you're ahead of me on that, right? But the PE exam, or mostly the FE exam, the Fundamentals of Engineering exam, does have a little bit of statistics, right? So am I screwed for not knowing statistics? No, because I can still figure it out using the resources that are available, right? So that's what I mean about being an engineer means how to work through new problems on your own, right? So it is a summary of most things you learned in college. So the best time to usually take the FE exam is like very soon out of college while it's still fresh.
Okay, excellent. So we are coming short on time, so we're just going to answer a couple more questions from the Q&A.
Yeah. I am also able to stay on a little bit longer if there
Oh, okay.
are just a handful of questions, right? Where it
All
doesn't
right,
have to end at the top of
fantastic.
the hour.
Okay, sounds good. I have a question here. I think it's from a student. How do you find internships for, I guess, regular high school students? What's that process look like?
Oh, that's a really good question. Again, I can't speak for that because I didn't apply in high school or college, but I did apply to jobs.
Mhm.
And pretty much my best advice for that is apply to as much as you can find and whatever interests you, right? Because let's be honest, once you do start applying to jobs and internships, you're gonna get a lot of rejections. Don't take it too personally, right? Just keep moving forward. Someone will eventually say yes the longer you apply, right? So don't give up on that. But there are certainly ways that you can better your chances of getting those internships. One of them is networking, making friends, building bridges with people, and not burning them down, right? Going to career fairs. It's that sounds so much easier said than done. It is very, very daunting to go to those career fairs, but put yourself out there, challenge yourself to put yourself out there. If you don't feel comfortable going to career fairs yet or talking to people, giving an elevator pitch, um, what can you do to get you to that point, right? Maybe you can take on some other extracurriculars where you can build up on those public speaking skills a little bit more and selling yourself a little bit more. Um, right? Taking on leadership in certain clubs. So first you'll have to become a member, and then you'll take on a leadership role where you're more responsible and whatnot. Um, all of those things are building blocks for you to eventually get to an internship and a job.
And kind of going off of that, when you do reach out to these individuals for internships, you're going to want to prepare accordingly, whether that's being authentic in the messages you do send out, but also having other people vouch for you. So whether that's
Mm-hmm.
teachers, maybe colleagues, or team members you worked with, anyone that can speak a little bit on your character is definitely going to help add a little bit of oomph to that. Okay.
Absolutely. Yes, you do want to be genuine. So with the connections that you have, you want to be genuine. So if you want to get a letter of recommendation from a professor, don't just go to the professor and say, "Hey, I've been in your class. I went to a couple of your office hours. I like you a lot. Can I get a letter of recommendation?" Right? Get to know the professor. Remember that your professors are teachers, or not. They're not teachers. Well, they are teachers, but they're people as well, right? So they have their own personal lives outside of school or outside of teaching as well. So I had a professor that was into stocks and traveling. I had a professor who was raising a newborn. Right? Everyone has their own lives. If you treat them like a person, like how they want to, like how you want to be treated, the golden rule, then you better your chances that way too as well. Just be genuine.
Amazing. Okay. So the last few questions here. Do you think as AI develops, that psychology will be more relevant to computer science slash other engineering fields?
I would say psychology is relevant in the past, present, and future, right? Just knowing how people think, whether that's with technology or not, is super critical. Um, I actually took a psychology course, probably the equivalent of AP Psych in high school, as one of my GE classes in college, and I would say that helped open up, the different ways I know how people think now. Like I learned about Pavlov. Okay, sometimes you have to Pavlov somebody into doing something, right? Then you can use that to your advantage a little bit. So knowing how people think and being persuasive, right? That all kind of helps you out and builds up on you. So
Okay.
kind of unrelated to AI, right? But even if AI is coming along the ways, you're still gonna want to maintain those personal connections with people, and that's all psychology there.
Okay. Um, is there any engineering field you would say to avoid due to potentially a terrible job market? Um,
Hmm.
it's a bit of an interesting one, yeah.
It is an interesting one. Um, it's tough to say because everything is very turbulent. Um, and that's not just with engineering. That's with any type of job. Um, take the thing I can think of right now is air traffic controllers. Um, they were promised stable pay, high pay for not a lot of knowledge, and something like a government shutdown can change all of that for them in the blink of an eye, right? So stability is very subjective. So if you're watching the current markets right now on tech, they're also very turbulent, right? So that's why instead of trying to time the market, to time everything, you don't have to worry about that if you are doing something that you enjoy. But to kind of sum it all up, engineering is naturally very turbulent, but it is also very rewarding.
Okay. And I think we're coming up to the last question here. A lot of people are curious about, AI engineering at UCSD. I know they opened a new BS for artificial intelligence engineering. I think we talked a little bit about the changing field and the role AI has in these fields, but what do you think about students kind of getting a head start at, one of the UCs, like UCSD, for example?
I think it's great. The more that you can put on your resume, the better. Um, I can't speak for UCSD. I didn't go there. I didn't even know they had an AI program there, so that's new to me. Um, so that being kind of a short answer, I can probably answer one or two more questions if you have them.
I think that's it for now. If anyone has any last minute questions, we'll leave it up for a little bit. But all of this will be available for later access as well. I think Julian can go into that a little bit.
Yeah, I think let's wrap things up. So welcome, I'm sorry, not welcome, but thank you so much for attending today's webinar. And as I mentioned before, we'll have this recording sent to you by email as early as tomorrow. All right. Thanks, everybody. Good night.
Thanks, everyone.